Good morning, everyone. This is Sarvesh, and I'm going to be your instructor for the day end course. A quick confirmation if all of you can hear me loud and clear, please. Thank you so much. We have been joined by Bhanu. He is starting from today. Thank you so much, Bhanu, and I welcome you to the training. Thank you so much. I'll just be waiting for 1 more minute for other participants to join in, and then we'll get started. Thank you so much. So, fine, guys, let's get started. So last class, yesterday, we had a very good discussion onto the introduction of big data. We talked about as to what big data is all about, and at the same time, we also talked about the different characteristics of the big data. And then we took this discussion further, and we talked about uh, the different sources of big data, and at the same time, we also learned one very important concept where we said that when you talk about RDBMS is a schema on write, whereas Hadoop is a schema on read, right? So these are the multiple stuff that we covered yesterday, and then we talked about the different sources of big data, right? So different sources of big data when you were talking, so we basically understood. Oh, screen is not shared. Give me a minute. The screen is not visible, right? Let me share that. Give me a minute. Is it visible now? Fine then. I hope I'm loud and clear and my screen is visible. And then at the end of the class, we said that why we want to process our data using Hadoop. And first of all, we understood like why the processing of the data is at all required. So we talked about it in a very good manner, and we said that there is some meaningful information that is hidden inside our data, and the ultimate purpose of doing this complete processing is we want to extract that information out of it, and that meaningful information as an IT person we want to provide to our business so that we can basically work as an enabler to our business, and we can make this information available to business so that business can use this information and can take the data driven decision at the right time, because it is all about taking the decision at the right time, because if you're not doing that you will be thrown out of the race. Being this a very high competitive market, you have to take the decision and the right decision. So those decisions should not be emotion driven, it should be a data driven decision. It should be a well thought decision that you have to take. So this data is basically enabling you to take those decisions, right? This data processing, this meaningful information. So, in today's world, the race is all about taking the right decision at the right time, right, guys? Do you all agree this point that yes, there is a race in the market, and the one who is going to win this race is the one who is going to take the decision right time, and that to those decisions has to be the data-driven decision. It should not be a manual decision or something like that. Do you all agree to this point that yes, it is very important to get this meaningful information out of the data? And then at the very last of the class, what we did yesterday is we said that okay, fine, we understand that these decisions are very very important to take, but why we require a new system called Hadoop to process this data was already there, this information was already there with us. If you process this data, you will get some meaningful information out of it, right? So that knowledge was with us, that data was with us, then why we were not processing it earlier, why we were waiting for one tool to come into the market called Hadoop? So we said that earlier we were not capable enough to process this data using those existing systems, and actually that capability, that enability came to us only and only when Hadoop came into the market. So we said that okay, fine. Now we are interested into coming to know that what are the limitation of the existing system and as to how Hadoop is overcoming those limitations. So why I'm talking about yesterday's class in more detail, because there are many participants who are saying that they are joining today. They were not yesterday. So my humble request to those participants would be that you go through the recording, and at the same time make yourself comfortable, and you feel comfortable today. That's why I did a quick revision of what we did yesterday, right? So fine. So first problem that we discussed with any of the existing system, we said that for any of the system, you can increase the RAM capacity, the hard disk capacity, and the CPU capacity. You can increase, you can increase, you can increase, and you can keep on increasing. But there is a threshold associated to it. There is a threshold associated to it. So I'm saying that yes, you can increase, but you cannot keep on increasing to the infinite level. You cannot keep on increasing to infinite level. There is a threshold associated. You cannot go beyond that. It means there is a maximum limit associated. So this problem is there with every of the existing system, that you cannot go beyond a certain limit, and that problem is there with every of the existing system, and that problem is basically referred as the problem of vertical scaling. So do I get a quick confirmation you understand the first limitation of the existing system that is available in terms of something called vertical scaling? Everyone in the class, guys, I requested this point very clearly to all of you, that we are not sitting in a physical class. So once I explain a topic, I would be taking the confirmation, and I'm expecting the response from everyone in terms of Y or K, and I'm expecting this response from all the 50 participants, please. Wonderful. Wonderful. Thank you so much. Thank you so much, everyone. So we now want to understand how we are going to overcome this limitation, how this problem is going to be sorted out in Hadoop, right? So in Hadoop, in Hadoop, what happens is, let me draw it. Give me a minute. So Hadoop says, what Hadoop says? So let me say this was the machine. So yesterday we were having discussion with, we were saying that, so we took the example of whom? We took the example Pradeep. So we said that Pradeep was able to process 20 GB of data onto one system. Let me say this was the machine he was using. This was the system. This was the system that Pradeep was using, right? So Pradeep was able to process 20 GB data onto this machine. Now the data volume is going beyond 20 GB. Data volume is going beyond 20 GB. So what Hadoop says? Hadoop says, boss, I'm not going to fight with a single machine. I'm not going to fight with a single machine. What Hadoop says, if you require more capacity, I will not fight with this machine, I will add one more machine. Now together as a whole, these two machines are going to work in coordination with each other, and together as a whole they will be able to process 20 plus 20, that is 40 GB of data, right? So this system is now capable enough to process 40 GB of data. Now your data volume is going beyond 40 GB. Hadoop keeps the stand and says that once again, I'm not going to fight with this machine. To increase the capacity, I will add one more machine. Now together as a whole, these three machines are going to process 20 plus 20 plus 20, that is 60 GB of data. You require more capacity, add one more machine. Now you will say, Sarvesh, what's going on? How many machines can we keep on adding like this? Guys, let me answer this question in a very, very straightforward manner. Guys, there is no limit. There is absolutely no limit on how many number of machines
You can keep on adding like this. There is absolutely no limit to it. You can keep on adding any number of machine. And what was the problem statement? The problem statement into the existing system was available in something called vertical scaling, and Hadoop is giving us the solution with a new tool or the terminology called horizontal scaling. So Hadoop says that you keep on adding the machines and there is no limit to it. So this solution is basically referred as horizontal scaling. Can I get a quick round of confirmation? You understand the problem of the existing system and you understand how Hadoop is overcoming this limitation with this innovative thought called horizontal scaling, please. Everyone in the class, can I get a quick confirmation? Very good. So if you look at it very carefully, this is quite a innovative solution that Hadoop has given. Now, if I talk about Hadoop, so let me say this resulting system I am representing with the help of this box. This resulting system I'm just representing with the help of this box. So let me be very clear about this box that this is a physical machine, this is a physical machine, this is a physical machine, and this is also a physical machine, right? So these are the physical machine. This box is just the representation of these physical machines. So if I talk about the hard disk capacity of the resulting system, I would say that, so what would you talk about? You would say that I have got a cluster, I have got a system, I've got an arrangement which can process 20 plus 20 plus 20 plus 20, that is 80 GB of data. So I would say that hard disk capacity of this resulting system would be the hard disk capacity of the first machine plus the hard disk capacity of the second machine plus the hard disk capacity of the third machine and plus hard disk capacity of the fourth machine. Similarly, Similarly, if we talk about the RAM capacity, the RAM capacity is going to be the RAM capacity of the first machine, second machine, third machine, and fourth machine. Similarly, if you talk about the CPU capacity, the CPU capacity is going to be the total. Aslam is asking, is this class is a live class or recorded class? Why that doubt is coming, Aslam? This class is a live class. I'm explaining the things right here, and if you have any questions, I can answer them right here. Any problem, Aslam? Any concern or something? Am I audible, Aslam? Because my mic is muted. So every participant is muted by the organizer here. The thought behind this is this class is being recorded. This class is being recorded. Guys, please understand one thing. The only thing which will be left out with you after the end of this training will be these recordings. So Edureka, make sure that the recordings that you are getting, those recordings are of supreme quality, and that is the reason they are saying that we are going to keep everyone on mute, and if you have any question to ask, you can always ask those questions by typing them into the question window, and I'm going to read it out for everyone. Yeah, you can ask questions any point in time, but you were not there yesterday, Aslam. I think you were there yesterday as well. So we talked about it, right? That you can ask me the questions at any point in time, but at the same time, I also requested that you please allow me to complete one topic, one discussion, a logical discussion, and once I come to the end of that discussion, then you are free to ask any question. In fact, you can ask any time, but that would be my humble submission that you allow me to talk about a topic for some time, and most of the questions are going to be answered automatically in that discussion itself. Is that okay, Aslam? Do I answer your question, please? Wonderful. Wonderful. Thank you so much. Thank you so much. So I'm sorry, guys, I got deviated. There was a question in between, and that is the reason I say that you should not ask the questions in between, because that basically deviates us from the current discussion. And so, okay, let's come back. So we are saying that the resulting capacity of the resulting system would be something like this, right? I just want everyone to think about it. So my question is, do we have any physical machine available with us? Do we have any physical machine available with us which can process 80 GB of data? I want everyone to think about it carefully and answer me yes and no. Do we have any physical machine available here which can process 80 GB of data? Do we have any physical machine which can process 80 GB of data? Yes or no? I'm not talking about physical data, I'm talking about physical machines. Guys, please look at the diagram carefully and just answer me as per this diagram. In this diagram, do we have any physical machine available which can process 80 GB of data, please? So, everyone in the class is saying that Sarvesh, there is no physical machine available here. There is no physical machine available here which can process 80 GB of data. If you talk about the physical machine, this is a 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 physical machine. All these individual machines can process 20 GB of data. This box, this box is not a physical machine, it is just a representation. It is just a representation of the four physical machines underneath. So this box which I'm highlighting right in front of you, this is not a physical machine, this is just a representation of the four physical machines underneath. This is not a physical machine, so this is basically a virtual file system. This is a virtual file system, and this virtual file system is referred as HDFS, and the full form is Hadoop Distributed File System. Can I get a quick round of confirmation you understand as to why I am referring this system to be virtual? Everyone, please, I want this confirmation from everyone. Do you understand why I am calling it virtual? What is the reason behind it? I'm waiting for your confirmation, please. Because it is logical and not physical, and you are absolutely right, Biplab and Benu. So let me move further. Aslam, we have never talked about the processing of the data so far. We are just starting our discussion, and there are so many things which are going to come your way. We have not even talked about the processing of the data so far. Is that okay? Fine. So, guys, you got to give me a minute, please. Sorry about it. Let's continue. So I was saying that if you look at this machine you can give it any name. You can call it machine. You can call it server, you can call it node, or 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 any other name that you want to give it. That is perfectly all right, right? So how I'm going to talk about this particular arrangement, I would talk about it this way. I would say that I have got what? I have got a Hadoop cluster. I've got a Hadoop cluster. So I would say that this Hadoop cluster which we am talking, this is basically a four machine or four node Hadoop cluster. This is a four node Hadoop cluster. This is how we are going to refer to it. I'm very sure you are with me, you understand this point, right? So this is a four node Hadoop cluster. So I'm very sure that with this diagram, with this discussion, you must have understood that the limitation with the existing system was available in something called vertical scaling, and the solution is given by Hadoop by this innovative solution called horizontal scaling, where we keep on adding the number of machines to get a truly infinitely scalable system. So the system, the Hadoop cluster that you have got right in front of you, this is a truly infinitely scalable system. Why infinitely scalable? Because there is no limit onto the number of machines that you can keep on adding like this. There is absolutely no limit, right guys? So the first question that is somebody going to ask you in your interview. So if you are appearing for an interview, very probable is that the first question that will be asked to you will be something like this. They will ask you, okay, fine, tell me the configuration of your Hadoop cluster that you're working on. So if you are going to appear in the interview saying that I have just completed a training, it might not help. So you have to say very clearly that I have been working into the Hadoop world for last 10 year or last 2 years or something like that. So the first question they will ask you, they will say, okay, fine, tell me the configuration of the Hadoop cluster that you're working on. So if you ask me this question, if you ask me this question as my interviewer, how I am going to answer this question, I'm going to answer it this way. And I would request everyone to listen to this carefully. I will say that I'm working on a Hadoop cluster, which is a 12,000 node Hadoop cluster, which is a 12,000 node Hadoop cluster. Now, the capacity of one machine out of these 12,000 machines is something like this. It is going to be 40 terabytes of hard disk. It is 512 GB of RAM and it is 256 cores. It is 256 of course. This is the capacity of one machine. So if you talk about the total capacity of your cluster, that would be multiplied by 12,000. So that is what is going to be the capacity of my Hadoop cluster. Can I get a quick round of confirmation? This piece is very clear to everyone in the class, please. Wonderful. Wonderful. Thank you so much. Thank you so much, everyone. So it is talking about the CPU capacity. Is that okay? Kaniskar? Okay. So we are very clear onto the first problem of the existing system. We have talked about the solution as well. Now let's talk about, yes, it is random only. So it will depend onto the PO that you are raising, purchase order that you are raising, right? Yes, Venu. Vaishnavi, are you with me? It is just an example that I have given to you. Venu, you are with me? Okay. So Sheikh is asking, is it required that every machine is to be of same configuration? No, it is not required. The different machines can be for the different capacity. Is that okay? The different machines can be of different capacity. Every machine can be of different capacity, but if you talk about the ideal situation, guys, please understand how it is going to happen. You are basically, so let me say, you take this training, and after this training you decide that you want to work with Hadoop in your organization. So you are going to create a Hadoop cluster. So the order that you will place, you will not say that, okay, fine, I want the one machine of this capacity, I want the other machine of this capacity, and the other machine of this capacity. No, you will simply raise a order. You will say that, okay, fine, I want to get started with, let me say 50 machines to start with, and the 50 machines capacity is going to be this one. Is that very clear, Sheikh and others? Guys, are you clear with the question from Sheikh? He was asking, are all the machines required to be of the same capacity, or they will be of different capacity? So theoretically, they can be of different capacity, but practically most of the time they are going to be of the same capacity every time. So 90% chances are there that they will be, not 90, 99% chances are there that they will be of same capacity. Do everyone understand this point? Sure, sure, Ayodhya. Thank you. Venkatesh is asking, do we need to pay for these 12,000 machines? What comes free of cost? Obviously, yes, we have to pay. Guys, I would highly appreciate if you please allow me to proceed further. Otherwise, this will become a Q&A session. I already talked about it that this is a 30 hours of training session. I cannot cover everything within 2 or 3 hours. You have to allow me to proceed further to answer further of your questions, and those questions are going to be answered automatically down the line. We have not completed the training. Initial configuration can be different, but how can we achieve the same? Manu, I would request you to please park your question as of now and let's move further. Is that okay, please? Fine then, let's move further. So what I want is, I want to talk about the other problem of the existing system. And for that particular stuff, what I want to do is, I want to talk about the database server, right? I want to talk about the database server. So yesterday when I was asking you what is structured data, everyone was replying that it is RDBMS, RDBMS and RDBMS. So it looked like that most of you are coming from the RDBMS background. So guys, can you please tell me, you all must have worked on database server. So what database server consists of? So let me refine my question. You talk about any database server, it consists of at least two physical machines. Can you please give me the name of those two physical machines? Can you please tell me, give me the name of those two physical machines, please? I get perfect response, absolutely perfect response from Uma. Very good, Uma. I highly appreciate that. Thank you so much. What is those two things called, Anubhava? Anubhav? What are those two machines called? You are responding absolutely correct, but can you please tell me what is the name? So I'm getting one very good response from Edureka Guest. Your name is appearing as Edureka Guest. I'm not very sure about your name. And I get the perfect response from Anubhav as well. And I'm getting the correct response from Ayodhya. So let me talk about it. Let me talk about it very, very clearly. So you talk about any database server, it consists of two physical machines. The first physical machine is basically your database itself. So we say that in our database we got tables, indexes, segments like partitions and all. So all those physical data, they are stored into this database. So this database is basically taking care of the storage part. This database is consisting of that storage. So you talk about any data, the table data, the index data, the partition data, everything is going to be available. Everything is going to be available into this particular database, into this particular storage unit, right? So every table, every index, everything is available into this particular table. So your table data is available in the files with some extension called d.dbf. I'm pretty sure all of you must be familiar with this. There are files with .dbf extension, database files, and this is where your data is available, right? Now what happens is, this is your first machine. Can you please tell me the name of the second machine now? Second machine is basically referred as instance. The second machine is basically referred as instance. So this instance machine is for the processing machine, is a processing machine, and this basically consists of the huge amount of RAM. This basically consists of huge amount of RAM. So whenever, as a user, when you're firing any query, whenever you're firing any query, let me say you're firing the query, select these columns from this table, and then you put some where condition or some group by condition or some where or some having condition. So whatever condition you're putting, so ultimately when you're firing this query, what you're doing is you're getting yourself connected to the instance. So you're getting yourself connected to the instance, and for this you are either forking a dedicated server connection or you are forking a shared server connection. But at the end of the day, you get connected, you get basically connected to the to this instance, and this dedicated server connection or the shared server connection is going to work on your behalf, and instance is going to help you. So what will happen, the table that you are looking forward for, the table that you're looking forward for, that table is going to be searched into this particular database. So your instance will go and check as to where the data, where the table is available, what you are looking forward for into this particular database. Let me say it finds it over here, right? Let me say it finds it over here. So once the table is found, what will happen is that table data will be coming to the RAM of this machine. That table data will be coming to the RAM of this machine, and that's where the processing will start. That's where the processing will start, and the output of that processing is something which will be submitted to the client. The output of the processing is something which will be submitted to the client, and that is how any of the database query is going to be fulfilled. That is how any of the database query is going to be fulfilled. So this is a very high level view of any of the database server. Can I get a quick round of confirmation that yes, you are clear with this and you understand it? Everyone in the class, please. Would highly appreciate faster responses. The class is having more than 50 participants, but I can say there are at least 4 or 5 participants who are not responding. Would highly appreciate them to please take part in the discussion. Thank you. So what is the problem in it? So we are here to understand the problem into the existing system, right? What is the problem in this arrangement? Can you please look at the diagram carefully and tell me what could be the possible problem here? So there are many people who are saying that Sarvesh, there would be limitation there would be limitation in terms of the storage into the database, and you are absolutely right. Guys, all of you are working professionals. You must have come across a situation multiple times when your DBA keeps coming to you and keeps bugging you that please remove some unwanted data, please remove the unwanted tables. If you have created any of the temporary table, just remove them, and he will ask you to remove some of the data and move it to the archival database. Does it happen with everyone? Your DBA keeps coming and bugging you? Does it happen? Can I get a quick round of confirmation, please? Does it happen with most of you? So everyone says that yes, it keeps on happening. So next time when your DBA comes to you, just ask him that why do you want me to remove my data? Instead of that, you should increase the capacity of this database. So your DBA is going to reply, your DBA is going to answer this question. Your DBA will say that, yes, I have already increased the capacity of this machine. Your data is going to be stored into this machine. I have already increased the capacity of this system to the maximum possible extent. This machine is also suffering from the problem of the vertical scaling, and I have already increased it to the maximum possible extent. I cannot go beyond this. I cannot go beyond this. I've already increased it. So guys, this problem is something that we have already covered here, and we have already talked about the solution of this problem. So yes, this problem is there with this system as well, but we are not here to talk about the same problem. There is one more problem here. There is one more problem here in this particular diagram, in this particular database server architecture. If you can please let me know that, that would be great, please. So let me answer this question on my own. If you look at it carefully, if you look at it carefully, what is happening when you're talking about this table? No, Kiran, that is not possible. In case of database, you are always going to have, always and always going to have a single database. You cannot store your data on multiple machines. That is for sure. So when you talk about the RDBMS system, when you talk about a database server, they have to be ACID compliant, and you cannot achieve the ACID property if you're going to keep your data onto multiple machines. That is basically the first rule of the database. Is that clear, Kiran? Okay. So the problem here is, if you're talking about this table data is searched into this particular database, and after that, that data for processing purpose is transferred to this machine, is transferred to this machine, and this transfer is going to happen over the network. This transfer of the data, obviously it is going to happen over the network. So the network is coming into the picture, so all the problems associated with the network will also come into the picture. Guys, please understand, there is a particular speed by which the data will be traveling over the network. Let me just talk about a very good speed and talk about the problem statement. Let me say the table that you are this table that you are trying to process, that table is of size, let me say 1 terabyte. Size of the table is 1 terabyte, and let me say we have got a very good transfer speed, let me say 100 megabytes per second. You have got a transfer speed of 100 megabytes per second. So if this is the transfer speed, can you please tell me how long it will take to transfer 1 terabyte of data from your database to your processing grid called instance? How long will it take, please? Can you do the quick mathematics and tell me the response? You can all make use of your calculators for it, but I would highly appreciate the response coming from everyone. I get the correct response so far only and only from Anubhav and Edureka guest, and from Dilip as well. And to some extent, I'm getting the correct response from Kaniskar as well. Kaniskar, you are approximately right, but not exactly right. Same is the case with Aslam. Very good, Sandeep, you are right. Guys, this is just a pure mathematical question, and I'm expecting the correct response from everyone, please. So let me do this calculation. Very good, Venkatesh. You are also right. Sandeep, Aslam. Very good, Aslam. Thank you so much. Shobha as well. Let me talk about it. Let me talk about it. Let me open my calculator. So what we want to do here is, okay, so we are talking about 1 terabyte. I get the perfect response from Kapil as well. Very good, Kapil. So we are talking about 1 terabyte of data. 1 terabyte is what? 1 terabyte is 1024 GB, right? And every GB is once again 1024 MB. So we are talking about we are talking about this much MB of data. We're talking about this much MB of data. And what is the transfer speed? The transfer speed is 100 megabytes per second. So let me divide it by 100. So it is going to take 10,485 seconds. It is going to take 10,485 seconds. To convert it into minutes, let me divide this by 60. This is going to take 174 minutes. It is going to take 174 minutes, and if I divide by 60 once again to convert it into hours, it is going to take 2.9 hours. It is going to take 2.9 hours. So if you look at it very carefully, when you want to fire this query, when you're firing this query, the data will be traveling from the storage grid to the processing grid, and just the transfer itself is going to take around 3 hours of time. Transfer itself is going to take around 3 hours of time. Forget about the processing. The processing is going to start after this. Processing is going to start after this. So it is going to take 3 hours of time, and that's where the problem comes in. And guys, I hope you remember our yesterday's discussion very clearly. We said that when you talk about big data, there is no end limit. There is no end limit. And if I just talk about that, okay, fine, I'm trying to process a file which is 1 petabyte, which is 1 petabyte. So 1 petabyte is what? 1 petabyte is 1024 terabytes. So let me multiply this by 1024. So it is going to take 2982 hours. It is going to take 2982 hours. Let me divide this by 24 to convert it to days. And it is going to take 124 days just to transfer the data. Just to transfer the data, it is going to take 124 days. Forget about the processing. It is going to start after that. Can I get a quick round of confirmation? You understand and appreciate the problem with this database server. Guys, please understand one thing very, very clearly. The database server is good enough. Is good enough if you are processing the small amount of data. So if I say that my volume of my table is 1 GB, that is 1024 MB. So it is going, let me divide this by 100 megabytes per second. So it is going to take 10 seconds of time, which is okay. Which is okay. I can wait for 10 seconds of time or something like that. But if you are asking me to wait for 125 days, that is not going to be acceptable. So thing is, if you are using your RDBMS system for processing some small amount of data, it is good enough for that. But it is not meant for big data processing. As the data volume keeps on increasing, the problem starts coming in. The problem starts coming in. Can I get a quick round of confirmation? You are absolutely clear onto the second problem of this existing systems. And what is the problem statement? The problem statement is all about transferring this data over the network. That's where the problem comes in. Are you all with me, please? Wonderful. Wonderful, guys. Thank you so much for such a great response. So let's talk about the solution given by Hadoop. And guys, this is an important discussion that we are going to have here. So in case of Hadoop, what is going to happen is, we already discussed this point that when you talk about Hadoop, Hadoop is working on the horizontal scalability. Hadoop is already working on this concept of horizontal scalability. So let me say I'm continuing with the same example of 4 machines. So before we go and talk about the solution given by Hadoop, we have to understand some other stuff. So guys, in case of Hadoop, what happens is, and listen to this very carefully, let me say what you're doing is you are storing this file. The name of the file is, let me say, abc.txt, and let me say it is of size, let me say it is 300 MB of size. 300 MB of data is not a big data. I'm just trying to make you understand with a simple example. So when this file is coming for the storage perspective in Hadoop, when this file is coming to Hadoop for this storage perspective, what is going to happen is this file is going to be divided into small blocks. This file is going to be divided into small blocks. These blocks are basically referred as data blocks. These blocks are referred as data blocks. And the size of these blocks, the default size is going to be 128 MB. So if the size of the block is 128 MB, can you please tell me how many blocks this file will get divided into? Wonderful. Wonderful. So this file will be divided into, so let me say this is the first block, this is B1. This would be of size what? This would be of size 128 MB. Another block of size 128 MB, right? So 128 plus 128 will be 256. So 300 minus 256 will be 44 MB. So the third block which will be there, that block would be of size 44 MB. So your file has got divided into three blocks. The first is B1 of 128, B2 128, and B3 44 MB. And once the data is divided into these blocks, what Hadoop is going to do, Hadoop is going to make B1 available onto this machine. Hadoop is going to make B1 available onto this machine, right guys? Hadoop is going to make B1 available into this machine. Let me say it makes B2, it makes B2 available. It makes B2 available onto this machine, and finally let me say it makes B3 available onto this machine. So first thing first that Hadoop did is Hadoop divided this particular file into multiple blocks and made those three blocks or multiple blocks available into the different physical machines. So this is what Hadoop is going to do with this file to start with. Guys, you should also understand one important thing about Hadoop. Hadoop is, right? Hadoop is a warm technology. Hadoop is a warm technology. What does it mean? It means that it is write once and read multiple times. What does it mean? It means that in Hadoop you're going to write your data only once. So when this file came to Hadoop, this will be written to Hadoop once. This will be written to Hadoop once in HDFS. It will be written to HDFS once, and after it has been written, it is going to remain there forever. We have already talked about that Hadoop is a truly infinitely scalable system. There is no limitation in terms of storage. Whenever you come across the problem of the storage, you can keep on adding the number of machines to the Hadoop cluster. So Hadoop is a truly infinitely scalable system, and because of that we are saying that we are going to write the data once, and after that the data will remain there forever. And after that you can read the data multiple times. So when I say read, I'm talking about read or process. You can read the data, you can process the data multiple times. Guys, do you all remember yesterday we talked about the CDR processing and we got that meaningful information out of it, the churn prediction part? So that is where the processing comes into picture. You can process the same data for some other purpose. You can process the same data for some other purpose. So that is what we are saying, that in Hadoop you're going to write your data once, and after that you will read or process your data multiple times. There is no limit to it. Are you all with me? Can I get a quick round of confirmation? You are with me, you understand warm, you understand write once and read multiple times. Everyone in the class, please. Yes, Sandeep, I'm getting your replies as well. Thank you so much. Fine. So moving ahead, now we want to process this data. So for processing, what you're doing, yes, Adi, I'm not sure how to pronounce your name. Should I refer you as Eddie? Ede? Ede. Ede is right. Okay, Ede, thank you so much. Okay, so moving ahead, what we want to do is, what we want to do is We want to process our data, and for processing, what you're doing, you're firing the queries. So guys, all of you are already a working professional. Can you tell me one thing? So I want to write my query. What is the highest lines of query that you have ever written in your career? I'm not talking about any stored procedure. I'm not talking about any package. I'm talking about a I'm talking about a query. What is the highest length of the query that you have written in your entire career? Can you please talk about it? Okay. So you can keep on doing the union. That is not going to make difference. So other than this union, it's okay. It's okay, Biplab. So the response which I'm getting, the biggest one, other than this union, I'm getting it from Vaishnavi. Vaishnavi is saying that she has written a query of 100 lines or 200 lines. That is such a huge query. So let me represent my logic this way, that this is the logic. So guys, if I go as per the response from Vaishnavi, which is the biggest one in the class, if I talk about this 100 lines of query, if I talk about this 100 lines of query, if I store this, if I open a notepad file here, if I open a notepad file here, and if I store those, if I store that 100 lines of query into this particular file, can you please tell me what will be the size of this file? If I talk about this 100 lines of query, this is going to be few kilobytes. It cannot go to megabytes for sure. It will be it will be maximum few kilobytes of query, not more than that. Do you all agree? Do you all appreciate this point that this particular file, which is going to have this 100 lines of query, this is just going to be few kilobytes of query. It will not be going to megabytes for sure. So the important point is what I'm trying to impress upon here is I'm saying that you talk about your logic. This is your processing logic. So this logic is going to be always and always of very, very small size as compared to the size of the data that you're trying to process with this particular logic. So this logic is going to be very, very small in size, few kilobytes of size. So what Hadoop says? What was the problem statement? The problem statement was you were transferring huge amount of data over the network. So what Hadoop says, boss, I'm not going to commit the same mistakes what my predecessors have committed. So Hadoop says that in Hadoop, we are going to write our data once. We are going to write our data once, and after that, your data will remain here forever. So when you want to process this data at time of processing, I'm not going to transfer the data. At time of processing, I'm not going to transfer the data. Instead of transferring the data over the network, what I'm going to do is I'm going to transfer this very small processing logic. I'm going to transfer this very, very small processing logic, and I'll make it available to every machine. I will make it available to every machine where my blocks are available. So instead of transferring the data, what we are transferring the very, very small processing logic, which is almost of negligible size as compared to the data. So can I get a quick round of confirmation? You understand this approach that Hadoop, instead of transferring the data, it is transferring the processing logic over the network, and that is how it is overcoming the problem of the existing system where the huge amount of data was transferred over the network when you wanted to process it. Are you all with me, guys? This is quite an innovative approach that Hadoop is coming out with, and should be. Could you please come again? I have been talking about every step so gradually, but if you want me to repeat, let me talk about it again. Ashutosh, what I'm saying is, did you understand this right once? So we are saying that we have already stored our data into the HDFS in terms of multiple blocks, and after that my data is going to remain here. Now what I want to do is I want to process the data. So Ashutosh, did you understand this point that this processing logic is almost of negligible size as compared to the data? Did you understand that point as well, Ashutosh? So what Hadoop says that my data is already here into these three machines in terms of these three blocks. So Hadoop says that I'm not going to move my data when I want to process it. When I want to process it, I will not be moving my data. Instead of moving the data, what I'm going to do, I'm going to make my processing logic. I will make this processing logic getting transferred over the network, and I'll make it available into all the machines where my blocks are available. I'll make it available into all the machines where my blocks are available. And that is how Hadoop is overcoming the problem. Ashutosh, you were there in yesterday's class. I gave you this example today as well. Were you there in yesterday's class, Ashutosh? Do you remember we talked about something called churn prediction yesterday? So that is what is called the processing. We talked about it very, very clearly yesterday that why we want to process this data. So we said that we want to get that meaningful information out of it. So that is what is the processing. We talked about it yesterday itself that why we want to process this data using a new system called Hadoop. So that is where the processing is coming into picture. No, it is not reading, it is processing. Processing means that, so tell me, if it is reading, was this info? Ashutosh, I would highly appreciate if you please come prepared in the classes. These all things were discussed in yesterday's class, and I do not want to take everyone's time to talk about the things which I have already talked about in the yesterday's class. I requested everyone, you should all be coming prepared in the classes. That is highly important. So yesterday we talked about it that this churn prediction information, what we are talking about, it is not readily available. It was not readily available. This is the information that we extracted out of the data, after processing. That information was never readily available. Right, Ashutosh? You are with me? That information was never readily available, and that is the reason we process this data to get this information out. And that is the same thing we are talking about today. We are saying that we can process this data, and whenever we are looking forward for processing, instead of transferring the data, I'm going to transfer the processing logic. Very good, Ade. Thank you so much. Got your point. We can move on. Thanks for explaining. Thanks for asking, but once again, would appreciate if you go through the recording, make yourself comfortable, and whenever you're joining the class, you should be absolutely clear what we have covered so far. Ashutosh, you should understand one thing, that each and every minute of this training should be utilized for some new learning, and that is the purpose we are here for. If I keep on talking about the previous thing, it is not going to be a value addition to you. I hope you understand. Fine, so let's move further. So guys, once again, there were so many questions. I want a quick response from everyone in the class. You understand what was the problem statement and how Hadoop has overcome that problem by not transferring the data but by transferring the very small processing logic over the network. Do you all understand this solution? Everyone in the class. It's a very, very important concept and everyone should be absolutely clear, please. Thank you so much. Thanks for such a great response. Highly appreciate that. Now, now, if you look at the solution very carefully, if you look at the solution very, very carefully, Hadoop is just not solving the problem. Hadoop is just not solving the problem. Hadoop is coming out with something very innovative. Hadoop is coming out with something very innovative. I would highly appreciate everyone to look at this solution once again carefully and tell me, in addition to solving the problem, Hadoop is achieving something great. Can you please look at the solution and tell me what that could be? It is written into the slide itself. It is there in the slide itself. Just you need to look at it carefully. I will obviously talk about it, but if you can respond prior to that, if you can think it on your own. Guys, let me just also make it clear. The way I proceed, the way I teach is, I want, I give you a problem statement. I want all of you to think about it. Please understand, if you are able to think about it on your own, that would be a permanent learning for you for the rest of your life. That learning is going to remain with you rest for continuously for your life. If you're not able to respond, I'm always here to answer those questions. I have already got the perfect, absolute perfect response from Kiran. Perfect. You are absolutely right, Anubhav. Thank you so much. So far it is Kiran and Anubhav who has responded correctly. So if you look at the solution very carefully, what is happening is we have transferred our processing logic to these three machines. Now what we wanted to do is we wanted to process this abc.txt file, and because of that we were processing block B1, block B2 and block B3. Now if you look at it very carefully, you are going to process block B1 into this machine, you are going to process B2 into this machine and B3 into this machine. So what is that is happening, if you look at it carefully, you are going to process this B1, B2 and B3 in parallel to each other. B1, B2, B3 are going to be processed at the same time. So what Hadoop is doing, Hadoop is basically playing the policy of divide and rule. So first it divided the data into multiple blocks, and later point in time when you are going to process them, you are going to process them in parallel to each other, and that is basically your parallel processing. This is also referred as This is also referred as distributed computation. So can I get a quick confirmation? This is very, very clear to everyone. Is it absolutely clear, guys? Do you really feel that this is a super feature available with Hadoop? It is always and always going to process your data in a parallel processing manner by default. And guys, this is the USP, unique selling point of Hadoop. People are coming to Hadoop mainly because of this reason, that they will be by default able to process the data in a parallel processing manner. So if you talk about Hadoop, Hadoop is what? Hadoop is a software, right? At the end of the day, Hadoop is what? Hadoop is a solution, it's a software. And I tell you one more wonderful feature about this solution, guys. You would be highly happy to know that when you talk about this software is available free of cost. It may look like a very simple statement coming from me, but just think about it. You don't have to pay anything for this software, not only for learning perspective, for your production perspective as well. You don't have to pay anything for it. What does it mean? It means this solution is available without any cost. Just compare this behavior with the hefty licensing cost that you have to pay for the other softwares like Oracle, Teradata, or SAP, or anything else. The hefty licensing cost that you have to pay there, here it is available absolutely free of cost. It's a community driven tool, it's a open source, it is free of cost. I hope you appreciate this point highly. So with all these things what we have covered so far, if I try to build the definition of Hadoop, so how would I define Hadoop? I would say Hadoop at the end of the day, it is a software, and the very important piece is that software is available free of cost. That software is available free of cost. And oh, I'm so sorry, I forgot to take the break. Guys, I'm extremely sorry. I'm supposed to take a break. I forgot about it. I was completely into the flow. I'm extremely sorry, guys. Thanks for reminding. Thanks for reminding. So going for a break right away. Going for a break right away. And thank you for reminding. Yeah. Thank you. So going for a break of 10 minutes, and then we'll come back and discuss the rest of the things after the break. Thank you so much. So welcome back everyone. A quick confirmation if all of you are back, please. Uh, Hari Babu, that depends on your profile. If you're coming from an admin profile, then you should go for admin. But I would uh, I would suggest you to go for the development one because that is more in demand into the market. Sure, Alok, I'll do that. Yeah, Hari Babu. Yes, Sandeep, tell me. Sarvesh, I'm not a working professional. I recently got graduated. Yeah, sure. Your good name, please? Would the query's logic only be transferred to units where the data blocks are available? How does the system decide which machine have the block for the desired query? We'll talk about it, don't worry. Sandeep, we'll talk about it. I'm parking your question, and this question will get answered automatically down the line. So, guys, you have to understand that not every question can be answered right away because we just started the course yesterday. So, we cannot answer every question right away. It might get answered automatically down the line. Sure, Bhargav, I'll take care of it. No worries. So we were talking about Hadoop and we were saying that Hadoop is a software which is available absolutely at free cost. You don't have to pay anything for it. And at the same time, this software is something which is solving the problem of the existing system. So it is overcoming the problem of vertical scaling with a new concept called horizontal scaling. At the same time, at the very same time, it is solving the problem of data getting transferred over the network by simply not transferring the data, but by transferring the very small processing logic over the network. And that is how it is overcoming the problem of data getting transferred over the network. The network problem is sorted out. And not only that, it is a infinitely scalable system. It is an infinitely scalable system, and finally it is going to process your data in a parallel processing manner or in a distributed computation manner. No, Hadoop is not an operating system. Hadoop is a software working on top of operating system. Right, Islam? So this is the definition of Hadoop. Can I get a quick round of confirmation? This definition of Hadoop is very clear to everyone. You understand every word of this definition, please. Aslam, you are with me? Perfect. So moving forward, if you just represent this definition to your management, what do you think your management is going to accept this question? Sorry, your management is going to accept this definition and will accept Hadoop as a new solution, or you think that they are going to ask you some questions on it? What do you think? What will happen in that case? What you think will happen in these cases? They will ask questions, okay? So what do you think? What will be the first question? What will be the first concern from their side? Very good. Very good. So I'm getting some very good response, like Aslam and many others. They're saying that the first question that your organization is going to raise, your management is going to raise, they will ask you, Okay, great. That's a great definition of the Hadoop that you are giving. So you are saying that Hadoop is a truly infinitely scalable system. That's a wonderful thing. And you are saying that you will keep on adding the machines. But they will ask you, are these machines coming free of cost? They will ask you, are these machines coming free of cost? So you are saying that software is absolutely free of cost. Good enough. What about the machines? Machines are not coming free of cost, right? So your organization will say that we have already invested a huge chunk of money onto the existing infrastructure. Now you want us to invest the same amount of money once again to set up a new Hadoop cluster. That would be too costly for us. So Hadoop has a solution to this problem as well. Hadoop has a solution to this problem. Hadoop says that we do not require the high-end configured machine, the server and configured machine. We do not require the huge machines. We do not require the high-end configured machines. We can work with normal hardware like your laptop or desktop. We can work with normal hardware like laptop or desktop, and this is basically referred as commodity hardware. This is basically referred as commodity hardware. So Hadoop is very clear on this piece that you don't have to invest the huge chunk of money on all this. Instead of investing huge chunk of money on all this, you can simply go for the commodity hardware. You can simply go for the commodity hardware. So commodity hardware is a cheaper hardware. So guys, if you just talk about your laptop or if you talk about your desktop, that may be very expensive for you. But if you talk about these hardwares with respect to the organization, this is almost of nothing. This is almost nothing. This is almost of zero cost. So now if I combine this particular part with the definition of Hadoop, we would say that Hadoop software is already free of cost. And Hadoop is going to make use of the commodity hardware, which is almost of zero cost. So as far as the investment is concerned, it is going to be nothing. It is already overcoming the problem of the existing system, solving the problem of vertical scaling with horizontal scaling, giving you a truly infinitely scalable system, and at the same time solving the other problem of data getting transferred over the network by simply not transferring the data but by transferring the processing logic. And at the same time, it is going to process your data in a parallel processing manner on a distributed computation manner. So this is what will come out to be the revised definition of Hadoop. Do you understand every word of this definition? Are you with me for this new definition of Hadoop, please? Wonderful. Wonderful. So do you find any further problem in this definition? If you look at this definition once again very carefully, you'll find that there is still some problem in this definition. Can you figure it out, please? I'm just asking you, there is still some problem in the definition of Hadoop. You can do a quick revision of this definition of Hadoop in your mind, and you can tell me what could be the possible problem. Anybody? I get the perfect response from Sandeep and from Anubhav as well, and from Kiran as well, and from Kapil as well. So what these guys are saying that Sarvesh, this looks like a perfect definition, but the problem in this definition is you are saying that you are going to store your data. So yesterday we talked about this data, right? This data is containing some meaningful information. So we said that this data is very, very crucial. This data is very, very highly important for all of us. So data is very, very important for all of us. And on the other hand, we are saying that we are going to store this data on a commodity hardware. What if the commodity hardware goes down? What if the commodity hardware goes down? So if it is a commodity hardware, its reliability is going to be on the lower side. So what will happen if the commodity hardware goes down? You will lose your data. Guys, can you afford to lose your data? We can't afford to lose our data. This is a very, very important data. It's an asset for the organization. It's an asset for the organization. You can't afford to lose your data. So if I come back to this solution, we are saying that in Hadoop we are using the commodity hardware, and because of that there are question marks raised. There are question marks raised onto the reliability part of the Hadoop, and whenever there is a problem, there is a solution given by Hadoop. So Hadoop has a solution to this problem as well. What Hadoop says, while I'm dividing this file into the multiple blocks, while I'm dividing this file into the multiple blocks, what I am going to do is, I'm going to, when I'm putting this B1 onto this machine, I'm going to create multiple copies of B1. I'm going to create multiple copies of B1, and I will keep it into the multiple machines. I will keep it into the multiple machines. So Hadoop says that I'm going to do data replication. This process is basically referred as data replication. And by default, Hadoop is going to keep 3 copies of it, and that is basically called the replication factor. That is basically referred as replication factor. So Hadoop says that I'm going to replicate the data, and I'm going to replicate it 3 times. It means if you talk about this B1, I'm going to create 3 copies of B1, and I will create these 3 copies into the 3 different physical machines. Same is going to be the case with this B2. Same is going to be the case with this B2. I'm going to create multiple copies of this B2, 3 copies, and I'm going to keep these 3 copies into the 3 different machine. Same is the case with this B3. I'm going to create multiple copies of B3. So I'm going to do it this way. Are you all with me? Can I get a quick round of confirmation you understand what Hadoop is doing to solve this problem of the reliability concerns? Hadoop is replicating the data. Hadoop says that, okay, fine. If I talk about a very bad scenario, I lose a machine. That means I'm losing this machine. So if you lose this machine, what you have lost is you have lost 1 copy of B1, 1 copy of B2, and 1 copy of B3. But that is not a problem at all, because you are still having the other copy of B1, other copy of B2, and other copy of B3 still available into the other machines. And this is how Hadoop is making sure that Hadoop is a highly reliable solution. Hadoop is a highly reliable solution. So if I just combine this particular part into the definition of Hadoop, the new definition of the Hadoop, Sandeep, the new definition of the Hadoop, Aslam was asking about it, I believe. So the definition of the Hadoop comes out to be like this. Some Edureka Gust was asking about it. So let me just talk about it. Hadoop is a software which is available free of cost. It is going to make use of commodity hardware which is going to be almost of zero cost. At the same time, it is going to replicate the data into the multiple machine to make sure that it is a highly reliable solution. and it is overcoming the problem of the vertical scaling by a new concept called horizontal scaling, which is making Hadoop a truly infinitely scalable system. And finally, it is overcoming the problem of data getting transferred over the network by simply not transferring the data, but by transferring the processing logic over the network and making sure that it is going to process your data in a parallel processing manner or a distributed computation manner at the end of the day. Right, guys? Kiran will talk about it. We'll talk about it. Give me some time. I cannot answer the question right away because more than clarification, it will create doubts. I want a quick round of confirmation from everyone if you are absolutely clear with this revised definition of Hadoop, please. So Sandeep is saying that you are replicating the data 3 times, that will waste your storage or something like that. Sandeep, please understand one thing. You're making use of commodity hardware. You're making use of commodity hardware. Even if you are replicating it 3 times, it is not going to increase your cost much. But at the same time, you will get high level of reliability. So you are getting the high level of reliability at a cheaper cost. I hope you understand. Vanilla will talk about it. Give me some time, please. We are just touching the points. So Vanilla is asking, how will it figure out what is written, which machine it has to look up for that block. We are going to talk about it. Give me some time. It is not something I can answer. Give me some time, please. I will have to park your question as well. And this question will be answered. This question is going to be answered in tomorrow's class automatically. Sandeep, to answer your question, this does not work. But theoretically, you can work onto the commodity hardware. Is that okay? So it is always an option available with you, Venkatesh. You want to go ahead with commodity hardware, you can always go ahead with that. Hadoop will not say no for it. And at the same time, it will give you the reliability as well. But your organizations are going to be more and more concerned about the security, about the not security, but about the reliability of your data. So they will always be going for the proper configuration of machine. I'm really not sure, Venkatesh, why you're asking this question. I think we had a very good discussion on this in our yesterday's class. There is no end limit. You're talking about 100 petabytes of data. 100 petabytes of data is no limit in case of big data, please. So at the end of the day, you should understand, even if it is commodity hardware, you can keep on adding them. It's a truly infinitely scalable system. I think we have talked about it. Right, Venkatesh? Okay, so guys, let me move further. Let me move further. How many of you have visited data centers? And if you have not, let me show you something. So your data center to some extent is going to look like this. If you have visited good enough, there might be some participants who may not have visited. So your data center is going to look like this. If you look at this, this is one machine. This is one machine, this is another machine, this is another machine, this is another machine, this is another machine. And like that, you can see there are huge number of machines, and this is one rack. This is called one rack. This is the another rack, this is the another rack, this is the another rack, and every rack is having huge number of servers. And you can see there are huge number of racks one after the other. Can you see this? And this is the walking passage. This is the walking passage. The same arrangement is here. Same arrangement is here. So this is how your data center, a typical data center is going to look like. You will be completely surrounded by servers and only these servers. And then what happens is, and then what happens is, the temperature of this data center is kept at low because there are huge number of machines working at the same time. So huge amount of heat will be dissipated. So to absorb that heat, the temperature of this data center is kept at very low temperature, right? So suddenly you will ask me why Sarvesh has started talking about it, because we want to talk about a very important concept called rack awareness, right? So you have got a very good idea as to how your data center looks like, and that's where I want to talk about a very important concept called. So if I give you a bigger picture of it, it is going to look like this. Your data center looks like this. If I stop this, so you can see this is one rack. This dot is one machine, this is a second machine, third machine, fourth machine, fifth machine, like that. And this is one rack, and you can see this is how your data center looks like. Are you all with me? Does this diagram give you more and more clarity, please? A quick round of confirmation, please. Everyone. This should give it more and more clarity to you. This is how your data center looks like. Fine. So let me just stop it. In fact, I should save this as well. Fine. Moving ahead. Now we want to actually talk about a important concept called rack awareness. So what is the concept of rack awareness? Let me first draw it and then I will explain it. So let me say this is your rack. This is what? This is your rack. So one rack has got what? One rack has got multiple servers. So let me say this is your one server, this is your second server, this is your third server, and this is your fourth server. Right? So you have got multiple servers available into one rack. You have got multiple servers into one rack, and this is how the arrangement is going to be, right? So how this arrangement is, so this is your rack 1, this is your rack 2, and this is your rack 3, and this is your node 1. So how this machine is going to be referred as, this machine will be referred as rack 1 node 1. What will be the name of this machine? The name of this machine will be rack 1 node 2. Similarly, what will be the name of this machine? It will be rack 2 node 5. And what will be the name of this machine, please? What will be the name of this machine? So it will be rack 3 node 12. It will be rack 3 node 12. So what is the concept of rack awareness? Let us try to understand. So we already know this piece, that whenever this file is coming to Hadoop for the storage perspective, what will happen is this file will be divided into three blocks, B1, B2, and B3. I'm sorry. I'm sorry, guys. So, if I talk about this B1, so what is the concept of rack awareness? The concept of rack awareness says that if you are keeping B1 onto this machine, right? So where are you keeping B1? You are keeping B1 onto this machine into this particular rack. So the other copy of this block B1, the other copy, we know that every block is going to be replicated 3 times. So when you are going to keep the other copy of B1, it will be there into the other rack. The other copy will be there into the other rack. Let me say it is here. And the third copy is going to be on the same rack but onto the other machine. So this is the concept of rack awareness. Rack awareness says that one copy is going to be on one rack and the two other copies will be onto the other rack, and total of 3 machines are going to be consumed. Total of 3 machines are going to be used for 3 copies, and all the 3 copies will be onto the 3 different machines and onto the 2 different racks. A quick round of confirmation, this is very clear to everyone. I don't know, but I'm not getting the faster responses. Now, if I talk about B2, let me say the first copy is available here. Can you please tell me where the second copy will go? So everyone says that it will either be going to rack 1 or it will be going to rack 3. So you are absolutely right. So the other copy can go to this rack or can go to this rack. Let me say I'm putting it into this rack. And the third copy will go to the same rack. Hope all of you understand and agree that the third copy will go to the same rack and it is going to be like this. Are you all with me for this arrangement? Very good. Similarly, if I talk about the B3, sorry, if I talk about B3, let me say the first copy of B1, B3, I'm making it available here. This is the second copy. This is the first copy of B3. I'm sure you understand that the second copy will be going to the other rack. So let me say it goes here. Let me say it goes here and the third copy is going to be here. The second copy is going to be here and the third copy is here. A quick round of confirmation. This complete arrangement is absolutely clear to everyone. Wonderful. Wonderful. So this is what is the rack awareness. So why it is so, so we are saying that, oh, I removed the third copy. So third copy is here. So why is it so? We are saying that if I lose one machine, if I lose, let me say I lose this machine. So if we are losing this machine, I'm losing one copy of B1, I'm losing one copy of B2, and I'm losing one copy of B3. But that is not a problem at all because the other copies are still available. B1 is here, B2 is here, and B3 is here. So I'm still having my copies available with myself. So it is not resulting into the data loss. If I talk about a worst case scenario, if I talk about a worst case scenario, if I say that I lose the complete rack itself, I say I'm losing this complete rack. That is also not a problem, because what you have lost is you have lost two copies of B1, one copy of B2 and one copy of B3, and you are still having your data available. You can see B1 is still available here, B2 is still available here, and your B3 is still available here. So you still have your data available, you are not losing it. So this rack awareness concept is there to ensure that even in the worst case scenario of the rack loss, you are still having your data available, and this is why this arrangement is done like this. Can I get a quick round of confirmation you are absolutely clear with this concept of rack awareness, please? Wonderful. And there are many questions that people are still asking. I have been requesting everyone to listen to the discussion when we are discussing something, but people are still writing the questions. I think I've talked about it multiple times, and when the discussion is going on, you should actually listen to the discussion. Now, if you have any question, you can ask me, please. B1 R1, B1 R2, and why not B1 R3? Okay, that's a very good question. What Venkatesh is asking, Venkatesh is saying, Sarvesh, you are making B1 the first copy available into this rack, the second copy into this rack. Don't you think if you make the third copy available into the third rack, that would be a more reliable solution? Don't you think that if you make the third copy available into the third rack, that would be more reliable solution? So of course, yes, that would be a more reliable solution, but at the same time, that is not something which is done in Hadoop. So what we are going to do is we will talk about it in tomorrow's class as a very first item as to why it is not done this way. Is that very clear to everyone? I will talk about it in tomorrow's class as a very first item as to why it is not done this way. There is a very logical reason behind it, and we will talk about it tomorrow. I have already got some response from Alok. You are absolutely right, Alok. We'll talk about it in detail in tomorrow's class. There is one more question. How can we replace the lost machine? So lost machine is a lost machine. I already talked about it that in Hadoop you can always keep on adding the machines. So it is a responsibility of your Hadoop administrator. He's going to do that. The third question is, will a new copy be made again as soon as the rack goes down as replication factor is 3? Yes, obviously yes. So that block will be under replicated, and whenever any block goes under replicated, the third copy or the second copy will be created once again. And how it is all done, that is something we will discuss when we will talk about something called write anatomy. Is that okay? Sarvesh, if we are storing all blocks in the same data center of region, failure of the data center. So you can always have your data available into the multiple data centers if you have got that facility available with you. So first of all, you have to set up a multi data center for yourself. Then you can make use of that portion as well. Is that also okay? I will wait for tomorrow's and then Hadoop decide to distribute this way. We'll talk about it. Any assignment due soon? So the only assignment I have already talked about it multiple times, that the only assignment would be the revision from your side. Do that very rigorously and make sure that you do it without fail. This is very important. So in case where we lose a rake, that data is available, but does Hadoop have any mechanism that will maintain? I have already talked about it. Right, Vanilla. Did racks are interconnected with each other? Obviously, yes. They are interconnected. The other question I have is from Vaishnavi. Is it with respect to Hadoop cluster? How to know Hadoop cluster configuration size? Get in touch with your Hadoop administrator. So Hadoop administrator, they would have got a single screen which talks about the complete architecture of the Hadoop that your Hadoop cluster has got, right? So for this, your point of contact should be your Hadoop administrator. Is that okay, Vaishnavi? And basically your Hadoop administrator can also extend the read-only view to you for that particular front end, and from there you can see that. Is that okay? So a final confirmation from everyone, if all of you are with me, please. Final confirmation for the day, if all of you are with me, I would highly appreciate all of you doing the proper revision. Guys, please understand one thing. I have parked some of your questions. I did not answer some of your questions because those were little advanced questions, and those questions are going to be answered automatically down the line. Please do not mind me parking any of your questions, right? I hope you understand the point. Everything cannot be covered within 4 hours of class. So we have so many things, we have so many hours to come up, and the things will become much more clear to all of you. So please do not mind me parking any of your question. I hope you all understand the point. There's many questions once again. It was a wonderful class, Sarvesh. Very, very highly concept building. Thank you. Very good. Very good. Thank you so much. Super class as it was yesterday. Thank you. Very good. Very good. Highly interactive session, Sarvesh. Your energy is highly appreciable. Thank you. Thank you so much. I appreciate that as well. Well done, Sarvesh. Thank you. Thank you so much. Super class once again. Thank you. Thank you so much. Crystal clear explanation throughout. Wonderful. Wonderful. Great class today too. Thank you so much. Thank you so much. You are a great teacher. Thank you so much, Ade. It was a wonder. It was a wonder class, and with wonderful class with wonderful examples. Thank you so much. Good session, Sarvesh. Thank you, Hari. Good session. Thank you, Sarvesh. Thank you. Thank you, everyone. So I think there is no other question here. Thank you so much. I appreciate all your beautiful comments, and would request all of you to please do the proper revision and come prepared in tomorrow's class. And till then, it's goodbye from my side. I'm going to meet you tomorrow at the same time, that is 7 a.m. IST. Thank you so much. Yeah, Sandeep, we'll do that. Yeah, Dhanashri. Thank you so much. Thanks, guys. Thank you so much for all the great comments that you're giving to me. I appreciate that. I mean it. Thank you. Fine. I'm calling it a day, closing the session.